It's 1:30, so I'll go ahead and introduce our next speaker. We have Aiden Lee, who's representing a group, and their solution to dog cannot catch. Go ahead, Aiden.
All right, hello everyone. My name is Aiden Lee, and this is our presentation for dog. We did the problem C, dog cannot catch, and we received the successful award. I'm a sophomore in high school, and I have only taken up until Calculus BC, which is roughly Calc 2 for college standards. And I participated in Scudem because I wanted the experience and I wanted to experience like a application-based first-hand approach, which there aren't that many opportunities in high school for this kind of math. So it was definitely a huge learning experience. So our team used two different models to see one that accounted for air resistance and one that didn't, in order to kind of see how important air resistance was in the graph, in the charts. So this model is the one without air resistance. So we assume that the Fritz and the dog are at fixed locations and the object is being thrown without air resistance. And here's a rough graph of the food being thrown to the dog. And so what I did was I represented the final velocity of the food object in terms of the initial velocity without accounting for air resistance. So we use the Pythagorean theorem and mostly high school level math in an algebra-based approach for this model. And we solve for the final velocity. We also solve for time using the distance between the Fritz and the owner. And then we solve for the vertical displacement of the food object using the initial velocity in the y direction, time, and the force of gravity to find vertical displacement in terms of initial conditions. So doing this, we could I graphed this to get a graph that roughly shows the relationship between the final velocity and the initial conditions and the initial velocity. So for this, we can find the relationship between how fast the food object would be approaching the dog versus what angle and how far the or the owner and the dog were. So that wasn't the case that vertical displacement did not matter, but in the case that we know how far the dog and the owner are apart in terms of height, we can solve for the vertical displacement to get vertical displacement in terms of the initial velocity and the initial angle. So that gives us, so then we could find the initial velocity and final velocity for a single point at a single vertical displacement point. And with this, we could solve that. In this example, the equation graphed would represent that the dog received the food 0.5 meters below the initial height, and that gives us a final velocity of 6.396 meters per second and an initial velocity of 5.56 meters per second. So from this, we can tell that the height and the distance matter in the final velocity of the object. And the second approach was that the second approach used air drag and gravity as the forces acting on the object. So from this, that we can see the difference between the first and the second models, and that they have different forces acting on the object. And the second model uses differential calculus, and we can represent the force as we can represent velocity and acceleration as the velocity as the integral of acceleration, and we are able to calculate that through, we can calculate that instead of just gravity acting on the vertical displacement, we can also see that air drag reduces the horizontal velocity as well. With this, we can see that the food object would travel at a slower horizontal velocity eventually and reach the ground earlier than in the first model. So what I gained from this challenge was that despite only receiving a successful award, and I learned a lot about mathematical modeling, and I was able to just learn a lot from the application base. So I was able to research what I needed for this specific challenge, and that taught me a lot more than if I were to just research the specific topic at hand. And I feel like as a high schooler, that definitely more high schoolers should be able to experience this kind of math, and that these opportunities should be like, and more high schoolers should be informed that this is a real thing. And yeah, so even if they're not particularly in advanced calculus, even with just like a calc 1 education, I feel like they could still reap the benefits of many of these specific problems, and they could kind of experience what it's like to research a specific problem in college through this. Yeah, any questions?
Hello, Aiden. I'd like to not ask a question, but give a comment. This was a wonderfully put together presentation. I really liked it. It got to the content of what you did, which the Scudam presentations I watched recently were just on process, and they didn't really give us the results. You gave us the results. And you gave us an excellent perspective on the whole situation being a high school student. And I really liked your showing the hand-drawn examples as part of your presentation. It gets a little monotonous when every slide has nothing but text. And I really like the fact you did better than that. It was an interesting, well-done presentation, and I'm awfully sorry more people weren't here to see it.
Yeah, thank you.
But since they're recorded, you know, that means that other people will look at it. It's awkward having so many presentations on the same topic at the same time. So I'm glad I chose yours. Thank you.
Thank you.
I think it's sort of funny that the schedule gives half-hour slots, but all these Scudam talks are 10 minutes. So it's an awkward situation to be in.
Yes, yeah. I just want to say that I feel like a lot of people have different approaches to the same problem, and I feel like it's really beneficial to look at the other people's recordings. So I definitely will be doing that. Especially because our approach wasn't like particularly novel or anything that special. It's just, for me personally, just being able to go through this process of like, oh, how should we go through this problem? Looking at the problem from different angles and just seeing how other people approach the same problem was really beneficial for me as a high schooler, especially. So, yeah.
May I say something to you? I really enjoyed this presentation, and Aiden explained the model, and I liked his use of hand drawings as well as nice, well-organized lists.
All right. Thank you, everyone. On that note, I guess we'll close up shop here. Thank you, Aiden, again for this lovely presentation and for doing this on your Saturday. Yeah,
Thank you,
thank you,
everyone.
everybody.
So, yeah.